you'll be pushing it by yourself. Be pushing that rail on the rheostat. Be pushing it. That is the meaning of adjusting the rheostat. And as you are moving that rail along this rheostat, you will be watching the reading of the voltmeter and watching the reading of the ammeter also.
Wait a minute, have you heard about Sa Majesty Easy Word? Well, I'm a subscriber to at Sa Majesty Easy Word on YouTube, and I'm a student at University of Camerino, Italy. Sa Majesty made science so easy for me, and it took away the fear I had on chemistry and biology. Distance is not the barrier. Guys, you have to join the Easy Word today at www.easywordscience.com and on YouTube at Sa Majesty Easy Word. Bye. Thank me later.
Hello students, this is Sa Majesty's Word. We want to take you on this practical aspect of physics known as electricity. It's a compulsory part in the practical physics every year. So we have to use this diagram here as a guide to teach you on how to. There are many diagrams you can see in electricity, many of them, different type of diagram. And to connect a circuit in the hall, most times it gives students some stress and some difficulties, but it's very simple. This diagram you're seeing here have apparatus joined together with the help of wires. You have E, this place where E is labeled is the source of power. Source of power. That is where we have the EMF of the cell, of the circuit. This one is the key, that's the socket. The socket, like a plug, you can call it a plug, where you can fix in something to close and the circuit is completed. This is where, when this thing is closed, we say that the circuit is completed. But if it is open, no flow of energy, no flow of electricity. This is ammeter here. This ammeter is an apparatus or a device that records current. That records current, which is measured in ampere. Ampere, the unit of current. This one here is V, the voltmeter. The voltmeter V. It records the potential difference across the circuits. The potential difference, the PD across the circuit is measured by this V, the voltmeter. And this one here is the resistor. Is a resistor of a certain ohm. It can be a standard resistor of 2 ohm. It can be of 5 ohm. It can be of 1 ohm. This one here is a symbol representing the rheostat. The rheostat. They offer some opposition. It offers some opposition to the flow of current. It can sometimes serve as a resistor on its own, the rheostat, as it's being connected in this circuit, because we provide them for this lesson. We provide this apparatus here for this lesson, provided the battery for the source of energy, the key, and the ammeter, the rheostat, the voltmeter, and the resistor, standard resistor, and some wires. This line drawn here they are wire. They're representing wires. In case if you are to connect, if you are trying to make a connection in the hall, just look at the diagram and follow it one after the other. You make a connection. Very simple. So now we can give you a diagram that looks like this, and at the end of the day, we transfer the diagram to look like this, depending on the question or the instruction being given to you in the question paper. But now we shall be looking at this particular diagram, which we may later transfer to this diagram. It depends on the instruction. So the instruction being given to you is this. Say, using this diagram now to follow an instruction. Say, connect, look at the question we are giving you. Connect the circuit as shown above, as you can see on the board. Close the key. Close the key. if you look at this diagram here, it doesn't have a key. The diagram doesn't have a key. But from this statement now, you will know that there must be a key in this diagram, which is not there. It is now left for you to put it. If you look at the diagram, there is no key. The question says, close the key and record the ammeter reading I0. Record the ammeter reading I0. When you close the key, you record the ammeter reading. That is the reading on this ammeter. This ammeter. When you read it, you call it I0. When you close the key. But look at this diagram now. You have no key. It have no key. That is why I say, using this statement now, I developed the diagram to this shape. Here, look at my own. My own now have a key. It say close the key. Okay, we are going the statement. Say connect. Okay, after closing the key, record the ammeter reading I0. Remove the plug. Remove the plug. Remove the plug of the key. That is the plug of the key. That thing you fix here to make the circuit closed. You remove it now. Most times when you remove it, it help you to sustain the energy here to avoid running the cell down. Because if you remove the key, no energy is flowing again until you return the key. Then you say, after removing the key of the plug, connect the voltmeter across the resistor. Connect the voltmeter across the resistor. Look at this diagram now. This diagram have no voltmeter. You have no voltmeter. But the question is telling you to connect it across. Connect the voltmeter across the resistor. R. Across the resistor R equals to 1 ohm. So that this thing here, this R here is 1 ohm. Is 1 ohm. Standard resistor of 1 ohm. That is what is provided. Be given to you. Then connect the voltmeter across the resistor equals to 1 ohm. And the rheostat in series with the resistor. Connect in series. Look at this statement now. You know that there is no voltmeter here. There is no rheostat here. They say you should connect. The question now say, by yourself, connect the voltmeter across the resistor and the rheostat being given to you in series with the provided resistor. In series, the series connection is end to end. End to end, end to end, end to end, in the same line. So this rheostat now, the question says I should connect it in series with the resistor, which is here. So which means I will connect that rheostat end to end, from this end to this end. To me, that is, but if it is in parallel, remember, rheostats can be connected in parallel. If they say in parallel, it's not going to be in the same line with this. This one is resistor. This one is now the rheostat. This connection now is in parallel. But if the question say this connection now is in series. Sorry, this one is in series. But if they say connect the rheostat in parallel with the resistor, I make this connection like this. I connect it like this. So that this connection now, this rheostat here, with respect to this resistor, is not in the same connection with this rheostat here in respect with this resistor. This one is in parallel. This one is in parallel with the resistor. And this one is in series. But the question says you should connect the rheostat in series. That is why we put it here to become end to end with the resistor. Then, and also the voltmeter across. The voltmeter across. This across is in parallel across the resistor and also across the rheostat. So that is why we developed this diagram now to have a voltmeter. This voltmeter here is in parallel with this rheostat and also the resistor R. That is why we say this diagram is being given to you. And from the statements, you develop it by yourself. As you can see on that screen, you read the question. Then, after connecting it in series with the resistor, so with the key closed, now return the key. Now return the key. Close this place. Use that plug and close here. With the key, that is what they mean by the key closed. The key is not the key used to open your door. This one is just a plug. Return that plug and close this hole. Then listen to the instruction after closing the key. Adjust the rheostat. This rheostat have a movable end on top of it. something you push it. That is what they mean by adjusting. You have a ring on it here that is movable. You'll be pushing it by yourself. Be pushing that rail on the rheostat. Be pushing it. That is the meaning of adjusting the rheostat. And as you are moving that rail along this rheostat, you will be watching the reading of the voltmeter and watching the reading of the ammeter also. Be moving it. If you are moving it, you watch the ammeter. Then the instruction says, close the key and adjust the rheostat. I have told you what I mean by adjust the rheostat. Adjust the rheostat. Be moving the rail. There is a rail, movable rail on the rheostat. You move it. You'll be moving it. That is the meaning of adjustment there on the rheostat. Then adjusting the rheostat to make the ammeter reading high, to make the ammeter, that is this one. You'll be adjusting it until this one have a reading of 0.4 ampere. You understand now? You'll be moving this thing. As you're moving, you'll be watching the ammeter. The pointer shaking. The pointer will be shaking until the pointer makes 0.4. You now stop adjusting the rheostat. Then take a reading of this ammeter. Look at it when it is 0.4. Stop moving the rheostat. Then come back at that particular point in time. Take a reading of this voltmeter that measures potential difference across the circuit. Then you record it. That one is I. When you record it, the reading of this one is called I. Remember, there is I0. I0. When the rheostats have not been adjusted, you call it I0. But on adjusting it, you get this one 0.4. Is I on its own, which is going to have a column in a table. You have your I, and you have your V. I in ampere. Current is ampere, and your V, voltmeter in volts. So now, by this time, this one records 0.4 ampere. You stop adjusting the rheostat. Then take a reading of this voltmeter at that particular point in time. Then, after doing that, you now continue again. You repeat the procedure by also adjusting the rheostat again to obtain a reading of 0.6. That is ammeter reading. When it is 0.6, when this one, just adjust this thing until this one now reads 0.6. When it reads 0.6, then take a reading of this one. You write it. Then after 0.6, you adjust again to obtain 0.8. Remember, I am using 0.4 here. 0.8, 0.6. Your own question, a question can come to you to get a current of 0.9, 0.8, or whatever, or 1.5, 1.8, 2 points. It's not a must that it will be like my own. I am using 0.4, 0.6, 0.8 as a reference. But your own question or your own instruction may say 0.8. Just follow the instruction. Follow the instruction, 0.8. But here I'm using 0.4, 0.6, 0.8. Then 0.8. After 0.8, you have 1, 1.2, and then finally 1.4. I divided my own into six major experiments from 0.4 to 1.4. 0.4, 0.6, 0.8, 1.0, 1.2, and 1.4. You stop there. Then at that time, you read the ammeter. Once this one read, you'll be moving this rheostat, adjusting the rheostat until you obtain a current of 0.6 here. Then stop. Check what this thing is reading. Write it under this V. Then after, you start moving the rheostat again. Adjust the rheostat again until this one record 0.8. Then stop and take a reading of this particular voltmeter here. Then write it down. Then after, you have your own table. Then we continue. You see, repeat the procedure for I equal to 0.6, 0.8, 1.0, 1.2, and 1.4. In each case, read and record the corresponding voltmeter reading, V. That is what I said before, V. Then tabulate your reading. Plot a graph of I against V. So in this case, there is no further evaluation. When they say plot a graph of I against V, my table will only have a serial number. Have a serial number Sn, I, and V only here. Because I don't need any other evaluation. Since they say that you should plot a graph of I against V. So no other values should come into the table apart from I and V. It's a very simple table. But there is something I want to let you know. In this case, if this diagram, like now, the look of this diagram here, I don't have to stress myself by doing the practical. If the diagrams appear like this, I don't have to stress myself because the current passing here is the same thing as the voltage here. If a diagram looks this way. So if this one here is 0.4 ampere, I should have a 0.4 volts in this one because of this connection. This one is in series with the rheostat, and this one is in parallel with the rheostat. Then since I have 0.4 here, ampere, I should also have a 0.4 volts here without even disturbing yourself going to do the practical. Yeah, and if I have 0.6 here, I should also have 0.6 here. So the reading here and here are the same. So you use it now, I against V, to plot your graph, which we will show you later. It's a very simple thing. But do not go and do as if you are doing the manipulation that they will see. If I should just, to make it a practical, because if you follow me with this thing now, all your points of the graph will enter, and it doesn't show any form of experiment. It means you're accurate, to no need of stating the precaution you took to ensure accurate results. So there is no error, no error. You can't say that there is an error when you have something practical, when you have it, you have the exact value. So if I should just make it look like a practical, if I have 0.4 here, I can have 0.39. I can make this one 0.39. I have 0.6 here. I can make this one 0.30. I can make it 0.30, 0.68. You understand? I will now come and check the difference between these two. Difference between the two, and be adding it gradually in each of them until I finish the value. Then I go and plot my graph. It's a very simple thing.
Hi, I wanted to tell you that you can contact Her Majesty Easy World for your laboratory equipment and reagents. They are affordable and provide accurate results too. Her Majesty Easy World only sells what he knows, and his patterns of delivery are sure and certain. Place your orders today. Thanks for your patronage.
Using my prepared filler, you can also place order for any of these apparatus and reagent to Her Majesty.